Hey everyone, my name is Alex. I'm a master's candidate here at Columbia, and this is my final research project presentation for speaker diarization for speech recognition. And I know we have only 3 minutes per speaker, so I'm going to go as quickly as possible. So just a really quick overview of the problem. I know I mentioned this in the proposal, but speaker diarization is when you want to tell who's talking when for multiple people who are speaking in a single file. So like, let's say that you're watching Good Morning America and you want to be able to tell when one of the anchors is talking versus another, maybe for automatic closed captioning. Well, this is exactly the problem. And then how do you do that? There's a couple different models in the state of the art that we'll get into. But obviously for this class, we worked out of Kaldi, but there are some pretty contemporary and good models that exist outside of that in Python. So one of those is the constant Q transform, and that was done with a CNN model built off of Keras. So I'm going to be comparing the results eventually to that. But there is a Kaldi EGS that exists for the AMI meeting corpus, which is the data set that I primarily used in addition to the ISCI, that is built off of the X vector features for the TDNN. So this is really bleeding edge state of the art and exactly where we want to use as a baseline. So what improvements did I make to this EGS for my project? Well, it actually doesn't work as it is. It's broken in this current state. So being able to fix that and get it up and running as it's supposed to be is going to be definitely an improvement. So the most egregious error that it's got is that it never actually creates the X vectors. Believe it or not, we don't have a call for that. We prepare the MFCC features and then we don't do anything with them. So, putting that in is the first thing. In addition to that, some more tricky ones is actually deep into the code outside of the shell script that runs everything. We've got some problems where it reaches out to URLs that are broken and don't exist anymore. And these URLs are changing almost every day, actually. This is so bleeding edge that we have files that are being rewritten and recreated pretty much every day, even as of the date of this recording. So being able to build our own manifest and lock that in with both AMI and ICI data. And then I built a script in Python to automatically split that into train, test, and development. So where are we at with this right now? It's actually still training with the TDNN, and I expect to have those results by Sunday and then compare it to the table below with the baseline for this EGS, as well as that constant Q transform one that was built in Keras. It'll be interesting to see how those compare. And then I obviously want to give back to the community so that Johns Hopkins latest version of this EGS, I'm going to be pushing my changes out in a pull request. And that's actually going to do it for me. And this is my last semester here at Columbia for the Masters. So here's a picture of me with my dog. And roar, lion, roar. Hope to see everyone at commencement. And thank you.